Can you explain the basic components of a typical home electrical system and their functions?
Great question. So I'd say it all starts from the service. You get EPCOR or Fortis, your utility provider, bringing power to your home, and that's going to come to the electrical meter. So that electrical meter is the responsibility of the homeowner, that box where your big plastic meter is going to plug into. So that box is a homeowner responsibility, and that part is where it really all starts. Then from there, you go to your first main panel or your first main disconnect, and that is the first point of disconnect before the utility provider. So that main disconnect is that's your biggest and most important breaker in the whole home. If that goes, you have no power to your whole house. Everything after that can be changed really at any point in time, meaning that if the power goes from there then down to your stove or to the plugs or to the lights, if they need to be worked on, they can be isolated at the panel via that branch circuit breaker. So after your main panel, then you might have other sub panels, maybe in a garage, maybe in a basement, maybe for something else. But it's pretty plain Jane simple for us after that. It's going to be plugs in your living areas and your kitchen. It's going to be lights in all rooms of the home. And it's going to be anything complicated past that, like energy management system, or maybe a hot tub, or maybe you're going to have air conditioning or a sauna. Anything with a high draw load is going to be a little bit out of the norm, but your typical loads are going to be your plugs, your lights, your counter plugs in your kitchen, sump pump, stove, dryer, and that pretty much covers the basics of your electrical system. And then anything after that is going to be extras or safety related, like your smoke detectors and your smoke CO detectors.
What are the common signs that indicate potential problems within a home's electrical system?
That's a great question too. So dimming lights and flickering lights. These are really two common calls that we get. And there is a difference. So dimming lights is going to be when you're running a hair straightener, or maybe your dryer kicks on or your furnace kicks on and your lights dim ever so subtly for a moment. That's okay. If they're not dimming out of the norm where it's an exorcist level of dimming, it's actually pretty typical for single phase power. But if you're having lights flickering, meaning that they go on and off, that's a connection problem, meaning there's going to be a break in the connection, or a connection isn't tight either at your switch or your light or somewhere in the feed, could be even at the breaker panel. As far as the dimming lights or the flickering lights, there's solutions for both, but oftentimes with dimming lights, it could be solved by poor grounding if it's excessive dimming, or it could be solved by bad light bulbs. Maybe they're really cheap bulbs and internally the LEDs just aren't up to snuff. As far as flickering lights, that's going to require an electrician's touch for sure, because somewhere there's a connection that needs a troubleshoot and repair.
How does the electrical system in older homes differ from those in newer constructions?
Good question. There's two big major shortcuts, and this is really going to upset a lot of people, but there's two big major shortcuts that a lot of builders take when building new homes. As far as receptacles in the walls, there's two ways of wiring a plug, and this is going to divide everyone. There's a backstab way, and there's a clockwise around the screw way. They're both code accepted, but we get tons of callouts, at least 4 every week, for new homes that are built in the last 20 years with backstabbed outlets where the backstab connection has failed. We've never had a plug where the screwed clockwise wire around the screw connection has failed. That says a lot, but there's still people that are going to defend that method, and the only really pro it has is that it's way faster. So when someone builds a home, they're going to backstab that wire because it's going to take them a minute of plug less than if you were to put the wire clockwise around the screw. By the other stretch, newer homes and older homes comes down to the grounding, your actual path back to earth, and your grounding electrode is what's going to activate your breaker. It's what's going to show that potential of 0 to the breaker to let it actually work. Your overcurrent device needs a source, needs a path back to earth in order to actually work. So if you have bad grounding, that's going to affect a lot of things. You're going to have fluctuating voltages, which is going to cook out circuit boards on a dishwasher, or maybe your washing machine, or maybe your fridge. But circuit boards need an exact voltage, and if you don't have a good ground, that voltage, it's going to create a lot of problems. With older homes, you're going to have a copper water line coming in the home, and that copper water line has kilometers of copper in the earth. That's perfect. Lots of source back to earth below the frost line. New homes, however, have a poly water line coming in, some sort of plastic plumbing piping coming in, we can't use that as a grounding electrode. So in those cases, you're either going to have a ground plate or a ground rod, most typically. So if you have 2 ground rods, they're going to be 10 feet deep, 10 feet apart, and they're going to be trenched 2 feet deep for the number 6 bear that's going to run from the rod to the rod back to your panel. That's a good grounding electrode because it's copper, because it's in the earth past the frost line, and because it's 10 feet apart and 10 feet deep. It's a lot of copper in the earth. But the other way you can do it is with a ground plate. And the ground plate's about 10 inches by 18 inches, maybe 1/2 inch to 3/4 inch thick, and only goes 2 feet deep. Now that's a galvanized steel plate. And if you're gonna have a metal plate in the earth, chances are pretty good it's gonna corrode and it's gonna rust. And given Alberta's really acidic soil, it will corrode and it will rust. So in 5, 10, 15 years, that ground plate is gonna rust up and you're gonna have a big ball of rust in the ground. And then you're gonna have no source back to earth. So a lot of homeowners end up calling and say, oh, my home was just built. Why are my lights dimming so excessively? Why are all my lights flickering? Why am I going through appliances? Well, it's probably because you have bad grounding. So what we do there is we call it the utility provider first thing to tighten their connections. And then if that doesn't work, we'll probably have to give you a quote to fix your grounding and put in 2 ground rods instead of that ground plate.
What safety risks should homeowners be aware of when it comes to their electrical systems?
The biggest risk with electrical is always shock. So if you ever see exposed metal parts around your plugs, your switches, maybe someone broke a faceplate because they were moving a couch, get that fixed up right away. The last thing you want is someone poking around with a knife, maybe a kid's crawling around, maybe a dog jumps up and hits that plug. We don't want to see anyone get shocked. So shock is always the number 1 concern. Anything after that, it's fire. The majority of house fires are from smoking and electrical, and there's no surprise there. But at the end of the day, if your electrical system isn't rated right, if you have maybe a 15 amp breaker and you have a 20 amp load plugged into that, you're going to overload the circuit and rely on the breaker to work. And if a breaker doesn't work, you might get that wire red hot and you might start a fire. So at the end of the day, knowing what your system is rated at and what each branch circuit is rated at is essential. If you have an overloaded circuit, then even if it's safe, you might not get shocked, but you might have an electrical fire.
How often should a home electrical system be inspected, and what does such an inspection entail?
It's a good question. I would call it an audit, because at the end of the day, to have an inspection, typically in our industry, would be related to a permit. So at Hauer Power Electrical, we don't do inspections, but we do audits in the sense that we're going to have an electrician, whether a journeyman or a master, come through and look at all the problem areas that we get to see in doing all the maintenance electrical that we get the opportunity to do. So for an inspection, typically a safety codes inspector would work for either the city or maybe a third-party company, and they would inspect a specific job pulled by a specific permit. So for us doing an audit on your system, the biggest things we would want to look at would be the panel, the first point of disconnection, your meter, your grounding, and anything after that would be more spot checks of plugs, lights, checking your switches for arc marks, and checking your plugs for correct polarity.
Can you explain the role of circuit breakers and how they function within the home electrical system?
Your circuit breaker is essentially your last line of defense when it comes to your electrical branch circuits. The whole point of a circuit breaker is when it sees a predetermined amount of current, its job is to open the circuit. That's what it's called, is an overcurrent device by code. So if you have, whether it's an electrical fuse or a circuit breaker, they're both operating on the same concept of overcurrent. They're not necessarily designed to pick up on arc faults or ground faults, because those would be covered with a ground fault circuit interrupter or an arc fault circuit interrupter, which you can also get in breaker form. But the whole point of a breaker is when it sees too much current, for example, 15 amps on a 15 amp breaker, then it opens a circuit. Its entire job is to protect the wire, not your device. But if your wire is rated for 15 amps, you're going to put it on a 15 amp breaker. If your wire is rated for 40 amps, you're not going to put it on a 15 amp breaker, because at the end of the day, you're wasting copper. If your wire was rated for 20 amps, again, you wouldn't put that on, say, a 40 amp breaker, because it would allow that circuit to draw way past what the wire is rated for.
What are some energy-efficient upgrades that homeowners can consider for their electrical systems?
A good energy-efficient upgrade could be a surge protector. Although our grid is quite stable, there is always going to be an influx of surges and hits. As long as there's mankind, there's human error, and as long as there's Mother Nature, there will be voltage spikes. So a surge protector would be the best thing you can do to keep your home's electronics safe and thus keep it running efficiently. Otherwise, getting rid of incandescent bulbs, halogen bulbs, and maybe other high-draw performing bulbs in exchange for LEDs would be a huge step in the right direction. LEDs are far more efficient, draw less power, and typically their luminosity is a lot brighter too. So that would be the number one go-to I would be to keep energy efficient.
How should homeowners approach doing minor electrical repairs or installations themselves?
That's a dangerous question. If you have a minor electrical repair or minor electrical installation, it's only easy until it's not. If you think that just changing a light fixture is easy, more often than not it probably will be. But once you open it up and start playing with the wires and it doesn't make sense, now if an electrician has to come in and piece it together how it would have made sense for him in the first place, and now it doesn't, might take him twice as long to figure it out and cost you twice as much. At the end of the day, it's good, if not just for peace of mind, at the end of the day, it's good to have it done right the first time rather than playing with something that you're not familiar with.
Looking forward, what innovations or changes do you anticipate in residential electrical systems?
Solar has made it clear that this is the way it has to go. So fortunately for a lot of homeowners, there's a lot of good solar companies out there. However, it still is very cost prohibitive as it requires a lot of upgrades in order to operate safely. Once the whole city can get on board and everything can go solar, we'll be that much closer to net zero. However, with big changes comes a big amount of time. With all the use of EV cars, we're seeing more and more that the grid, maybe even just our homes, can't support that amount of power. By the same stretch, when we see these Amber Alerts where it's asking us to unplug our car heaters, it tells us that the load might be a little bit much at certain times of the year. Same thing when it's peak plus 30 season and everyone's running around their air conditioners. That's going to be a bit much. So solar is definitely the next step up, because as humans, we love to suck the power out of everything we can. So yeah, where there's people, there's problems, but where there's people, there's solutions too. So I think if we can all go solar and get our panels upgraded to accommodate the solar change, we'll be in a good spot.